Start करें. Good morning students. Welcome you all to YouTube live classes of standard 11th chemistry class. I am SARITA MOHANTY from DEVI Women's HSS and I am teaching you unit 12th of your syllabus organic chemistry, some basic concepts and techniques. In the last class we discussed regarding resonance. What is resonance? How to write the resonating structures and what are donating groups and what are electron withdrawing groups according to resonance. And today we will start our class with what are the effects of resonance, then we will study hyperconjugation, then some reactive intermediates, and if possible we will also study the types of organic reaction. So, let us start the class with some effects of resonance. Now, as you know, resonance involves the shifting of the pi electrons. So, the effects of resonance is used or it can be used to describe the acidity and the basicity of organic compounds. Let us see the case of acetic acid. So, what is an acid? An acid is a substance which can give H plus ion easily. The more easier one can donate H plus ion, the more will be the acidity. So, suppose HA is there, HA is there, and if HA can give you H plus and A minus readily, then HA is called an acid. The more easily it can give the H plus ion, more is the acidity. So, this is called conjugate base, this is acid. So, if the conjugate base, we have to prove that the stability of A minus is more than that of the stability of the HA. आमे जानिछे नेचर रूल होची कोन जोटा जेते स्टेबल हबो सेटा सेते अधिक तयारी हो. So, if we can prove that A minus is more stable than HA, then we can prove indirectly that H plus will be created in more amount. A minus theory ho mane H plus भी theory ho. Okay? So, for a compound to be acidic, remember that we have to prove that its conjugate base is actually more stable than the molecule. So, let us see acetic acid. In case of acetic acid, we have to prove that its conjugate base, that is the acetate ion, must be more stable than the acetic acid, and it can be proved with the help of resonance. Let us write the resonating structure for acetic acid and acetate ion. For acetic acid, mark here, there is lone pair on oxygen, then there is single bond here and double bond. So, I have already discussed yesterday that lone pair, sigma bond, pi bond will give you resonance. So, here there is resonance. As a result of resonance, you mark here that the oxygen is developing a minus charge while OH is developing a positive charge. That is, dear student, mark here, there is charge separation, that is the positive and negative ions, positive and negative charges are present within the same molecule. आमे जानिछे the charge separation is due to the charge separation makes the molecule unstable. Sethipai it will not be counted for its resonance stability. But in case of acetate ion, mark here, in case of acetate ion, negative charge minus sigma bond, double bond. So, it can also give resonance. So, due to resonance, what happened? Now, due to resonance, mark here, due to resonance, CH3, C double bond O, O minus. So, mark here, due to resonance, equivalent contributing structures are actually getting produced for acetate ion. and which leads to its stability. So, now see, the resonance can be useful to explain the acidity of the organic compounds. With help of this, we have now proved that acetate ion is more stable, hence it will be produced in more amount, hence H plus ion will also be produced in more amount. So, now let us discuss another case, that is phenol. Why phenol is acidic? Phenol is acidic, the same logic, if we can prove that phenoxide ion, is more stable than the phenol, then phenol will be acidic. So, we have to write the resonating structure for phenoxide ion as well as for the phenol. These are the resonating structures for phenoxide. It is the resonating structure for phenol and these are the resonating structure of phenoxide ion. In case of phenol, lone pair, sigma bond, then double bond. So, it can produce resonance, already we have discussed in the previous class. So, dekho, oxygen donates the electron to the ring and now this pi bond will break over to the next carbon. It dekho minus charge hai na. Oxygen, since the oxygen gives the electron pair of own electron pair, se kon kala ring ku dela, sethi pai the oxygen will develop a positive charge. Eta dekho positive charge hai na, because se nijo electron ta ring ku de dela. Now this negative charge will migrate in the entire ring. Dekho, minus single bond, double bond. मन पकाओ काली रेजोनेंस रे पढ़ाई थिला. तो नेगेटिव चार्ज टा सबले कहा भितरु मूव करिवो, विद इन द बॉन्ड्स मूव कला, आउ एटा उठिला, ए जो डबल बॉन्ड टा भांगिला कहा उपरकू, एडजेसेंट कार्बन एटम पाखो. तो देखो एठी कोन हला, बर्तन देखो, इन द रेजोनेटिंग स्ट्रक्चर ऑफ फिनॉल we are in structure number 2, 3 and 4, there is charge separation, that is positive and negative charge are present within the same molecule and within very short distance ashanti. So, obviously due to charge separation these three structures will not contribute towards the stability of the molecule. तो एटा किछि contribute करिवो नाही, माने सेटा थाई कि जा that not hai ki bhi same. But in case of phenoxide mark, only a negative ion is migrating in the entire ring. O minus, ethi kon hala, already negative charge achi, this negative charge is shared by the oxygen. So, it becomes neutral, So, again minus, negative ion ta sabole mark karo, carbon bhitru ku move kala, and pi bond will move to the adjacent carbon. So, likewise you see in case of phenoxide ion, structure number 2, 3 and 4, they do not have any charge separation, only a single negative charge is revolving around the entire ring, that is the delocalization of the charge is taking place. Delocalization of charge. एथि कौन होची phenoxide ion रे ना delocalization of the charge. And remember that resonance टा कौन पाई हुए? Resonance occurs for the delocalization of the charge. More is the delocalization of the charge, more is the stability. देखो गोटे काम तुमको कहै छै एकुटिया करिया पे, से काम जब तुम दि तीन जन मिसी करबो तम ऊपर कोन हो हल्का. Similarly, if the charge get delocalized over a number of atoms, it becomes more stable. Okay. So, the resonance also helps us to explain the acidity of the phenol. Now, the resonance can also be used to explain the basicity of the organic compounds. Why? What is basicity? Basicity is the tendency to donate electron to H plus ion, simple language re koi periya. So, more easier one can donate its electron more will be the basicity. जेते सहजर इलेक्ट्रॉन दे परियो more will be the basicity. So for comparison, suppose this is actually aniline. Suppose methylamine and aniline, we have taken two cases, methylamine and aniline. Mark, both have lone pair of nitrogen. Lone pair of nitrogen achi. So which will be more basic? Now one which can donate the lone pair of electron more easily will be more basic. Now mark that in case of aniline, actually what happens? Now the lone pair, single bond, then double bond. So এটা কোন আছে? Conjugation রে আছে. The lone pair is in conjugation with the ring. Hence it get involved in the resonance. এটা কোন हुए? Resonance रे involved हो जाए. Suppose तुम पाखरे गोटे पेन टे थिला, तमे आउ गोटे पिला को दे देइछ. Can you share it more easily with another student? No. तो जेहेतु since the nitrogen has already shared its lone pair of electron with the ring, already shared the lone pair of electron with the ring, it cannot donate this electron more easily to H plus ion. एटा सहजरे H plus ion को देई परिबो नाही. Hence its basicity will decrease in comparison to methylamine, because in case of methylamine you will see, or ethylamine you will see, in case of ethylamine there is no possible resonance, hence also there is inductive effect, hence the lone pair on the nitrogen is completely available for any H plus ion. But in aniline this lone pair is shared with the ring, hence this is not completely available for the incoming H plus ion. So its basicity will decrease. Now let us start hyperconjugation. This is very important because hyperconjugation is used to explain many properties of the organic compounds. Let us see. Till now we have discussed resonance. And in resonance which electrons are moving? These are the pi electrons. In resonance it is the pi electrons which moves from one place to another. But in case of hyperconjugation, it is also called no bond resonance. We will see actually the sigma bond electron. Here it involves the sigma bond electrons, means the sigma bond electron will get involved in resonance. So what is hyperconjugation? Hyperconjugation is the partial delocalization of the sigma electrons or lone pair of electrons into the adjacent pi orbital or p orbital. It is the partial delocalization of the sigma electron. Sigma electron कौन करिवो ना निज पोजिशन रु adjacent जदि ता पाखरे किछि pi orbital अछि किबा p orbital अछि, it will get shifted there. It occurs due to it occurs due to overlapping of the sigma bonding orbital and the adjacent pi orbital or the vacant p orbital. It is also called Baker-Nathan effect. Hyperconjugation can be seen in carbocations, in free radicals, in alkenes. We will discuss it one by one. Okay? So let us see the hyperconjugation first, how the hyperconjugation is actually occurring in carbocations. This is actually our C2H5 plus, or I can say CH3 CH2 plus. This is ethyl carbocation. What is a carbocation? carbon with a positive charge is called a carbocation. We will discuss it later. Let us see here first. Mark that this carbocation, it is sp2 hybridized. So, sp2 hybridized means it will have a vacant p orbital. Here this is the vacant p orbital achi, but it is vacant. Now, this is a sigma bond formed between carbon and hydrogen. Carbon achi gote, ethi dekho kon hoichi na ethi this is carbon hydrogen, 3 carbon hydrogen sigma bonds are present, and there is a vacant p orbital on this CH2. So, this positive, this carbon is actually, dekho, this carbon is actually deficient in electron, here electron nahi. So, it will attract this sigma bond को कौन करिवो, sigma bond electron को it will attract निज आड़ को जानिवो. So, sometimes this carbon hydrogen sigma bond also moves into this vacant p orbital. So, माने कौन करे बेले बेले एठी के भी पळांती. This leads to hyperconjugation. Mark कलो, carbon hydrogen sigma bond अछि, adjacent carbon पाखरे जदि गोटे पाए अछि, पाए orbital अछि किंबा vacant p orbital अछि, then that sigma bond can sometimes migrate, then that sigma electron can sometimes migrate or move into this vacant orbital, and this leads to your hyperconjugation. Eta orbital theory अनुसार देखिले. Now let us see in a simpler term. Suppose लिखली carbon H and CH2 plus. Now this carbon is in the need of electron. So suppose, just think that this hydrogen gives the electron to this carbon and leave the space. Now it electron de de. Then it becomes, the structure become H C H double bond CH2. ये इलेक्ट्रॉन शेयर कला, जेहेतु निज इलेक्ट्रॉन दे देला, यार कौन हला, now it becomes, देखो केटा बॉन्ड है गला, चारटा बॉन्ड है गला, now its valency are satisfied, so no need to write positive charge. But since hydrogen loses its own electron, hence a positive charge will be there over hydrogen. Hydrogen ऊपर गोटे positive charge रहिबो. ए कार्बन नो देखो किछि चेंज हेनी, एठी भी बॉन्ड करथिला, एठी भी बॉन्ड कला, so this carbon remains same. Mark करो, this is hyperconjugation. This is hyperconjugation. Now, how many number of hydrogen are there? 1, 2, 3. Suppose this is A, B, C. So, this hydrogen can also donate electron 1. This second hydrogen can also donate electron 2. And this third hydrogen can also donate electron, that is 3. So, 3 times you can write the resonating structure or no bond resonating structure. Mark that here. This carbon which is attached to a positive carbon is called alpha carbon. The carbon which is attached to a carbocation is called alpha carbon, and the hydrogens which are attached to the alpha carbon are called alpha hydrogens. Remember that for hyperconjugation these alpha hydrogens are highly important. Our hyperconjugation ta kaha pai hue? The hyperconjugation occurs due to alpha hydrogen, and remember that number of hyperconjugating structures is equal to number of alpha hydrogens present. तो एठी केतरा alpha hydrogen अछि? This is alpha carbon. So 1, 2, 3. So for this carbocation we can write 3 hyperconjugating structures because of the presence of 3 alpha hydrogens. Similarly, the resonance can also, hyperconjugation can also occur like this. In case of alkenes, mark, this is the double bond carbon. The carbon which is attached to a double bonded carbon, here it is called alpha carbon. So, how many numbers of alpha hydrogens are present? 1, 2, 3. 3 numbers of alpha hydrogens are present. That means you can write 3 hyperconjugating structures for this alkene. Mark here. Kemti habo? First one, eita suppose asila. So, we will have H, C, H, double bond, CH, single bond, CH2 minus. Similarly, for this hydrogen you can also write another hyperconjugating structure, and for this hydrogen you can also write another hyperconjugating structure. Mark that since 3 alpha hydrogens are present, you can write 3 hyperconjugating structure. More the number of alpha hydrogen, more will be the hyperconjugation. So, definition ta मन रखता alpha hydrogen रे, जदि कार्बोकैटायन अच्छी, कार्बोकैटायन को जो कार्बन टा लागिची that is called alpha carbon. जदि डबल बॉन्ड अच्छी, डबल बॉन्ड को जो कार्बन टा adjacent लागिची that is called alpha carbon. और तुमको गणिबार अच्छी से adjacent carbon रे केतेटा हाइड्रोजन अच्छी. मार्क करो हाइड्रोजन जो आमे लिखिले या पूर्वरु this hydrogen actually this is the hyperconjugating structure जोटा कि बर्तन देखिली देखो this hydrogen actually do not leave the space ये कोड़े पढ़ाएनी it remain in that position and hence it is called no bond resonance because there is no bond between carbon and this hydrogen but still it is staying there, hence it is called no bond resonance and the position of the hydrogen or position of the hydrogen remains same. एटा मन रखथो सबले it do not go outside the molecule, एटा बाहर को जीव नहीं. So, now let us discuss what are the effects of hyperconjugation. Hyperconjugation jogu कौन effects आसे. This is very important because many of it cannot be explained with the help of inductive effect or resonance. It can only be explained with the help of hyperconjugation. So, stability of the alkenes. We know that more is the alkyl groups attached to carbon carbon double bond, more is the stability of the alkene. गोटे alkene रे मन रखता जेते directly methyl group alkyl groups लागिचंती carbon carbon double bond को सेते अधिक stability हबो. Greater the number of alkyl groups attached to a carbon carbon double bond, greater is the stability. এই কনসেপ্টটা মনে রাখিবো because it is very important not only for entrance जे पर्यंत केमिस्ट्री पढ़िबो alkene पढ़िबो एटा सब बेले दरकार आसीबो हला. त गोटे पर गोटे डिस्कस करिया केमती होची. Here there is a comparison between the different alkenes in case of ethene and in case of 2,3 dimethyl butene. Let us take two extreme cases. This one is having no alpha hydrogen at all and this one is having all the alkyl groups attached to it. So, let us discuss two extreme cases. So, in case of ethene, the simplest kind of alkene, so the simplest कोटा alkene, ethene, देखो के बड़ा हाइड्रोजन लगता है, देखो. Mark, is there any alpha hydrogen? No, because there is no alpha carbon itself. Definition one पका carbon carbon double bond को जो carbon लगी थी that is called alpha carbon and here there is no alpha carbon itself. Hence, there is no alpha hydrogen, hence no hyperconjugation. किछि hyperconjugation एठी possible ही नुहे due to lack of the alpha hydrogen. Now let us see another case, that is our এটা দেখো mark, this is your 2,3-dimethyl butene, a molecular name. देखो here all the hydrogen I have replaced all this hydrogen with methyl group. सबु hydrogen बदले देखो कौन लगी methyl group लगी. Now you calculate the number of resonating structures or sorry number of hyperconjugating structures. केतेटा अल्फा कार्बन अछि देखो कार्बन कार्बन डबल बॉन्ड को डायरेक्टली केटा कार्बन लगी 1 2 3 and 4. So there are 4 alpha carbon. जो hydrogen गुड़ा alpha carbon को लगता है, these are called alpha hydrogen. So calculate the number of alpha hydrogens. कितना है 3 plus 3 6 plus 6 कितना है? So 12 number of alpha hydrogens are present. That means you can write 12 conjugating hyperconjugating structures for this molecule. देखो केमती लिख पाइबा. देखो ए बॉन्ड टा एठी की माइग्रेट कला, then this bond will migrate to this carbon. This is one hyperconjugating structure. Then again देखो ए बॉन्ड टा एठी सपोज माइग्रेट कला, then this bond will migrate to this carbon. Similarly, this bond can migrate to this and this pi bond will break down over this carbon. So, see for each methyl group I can write 3 hyperconjugating structure for each methyl group. Hence, in total I can write 12 hyperconjugating structure for this molecule. So, remember that for if you are asked that how to calculate the stability of the alkene, you just calculate the number of alpha hydrogens, then you can know which alkene is more stable. More is the number of alpha hydrogen, more is the stability of the alkenes. एटा again आमे पढ़िबा कोथरे ना जेतोले आमे alkene पढ़िबा. Stability of the carbocation. What is the carbocation? Na carbon bearing a positive charge is called carbocation. The principle which is applicable for alkene is also applicable for the carbocation. The stability order of the carbocation is tertiary, greater than secondary, greater than primary. And this can be explained with the help of inductive effect as well as hyperconjugation, and we will discuss it. Mark, this is actually your ethyl carbocation, that is C ethyl carbocation. Here it is being written ethyl carbocation, that is C जोटा देखैथिली मु तुमको ऑलरेडी one 2 3. So, in case of ethyl carbocation, how many number of alpha hydrogens are there? मन पका alpha hydrogen रो definition कौन? The carbon which is directly attached to a positive charge carbon is called alpha carbon, and the hydrogens which are attached to that carbon are called alpha hydrogens. तो देखो एठी केतरा बॉन्ड ते लिख परछो 1 2 3. So, for ethyl carbocation you can write 3 कौन resonating 3 hyperconjugating structures. Like this C, C, H, 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 so here you will have C, H, H. You increase the number of alpha hydrogen, the number of hyperconjugating structure will also increase. देखिए, for example, let us take the example of dot butyl carbocation. Here mark that how many number of alpha hydrogens are actually there. Carbocation देखो, this is the carbocation. So, the carbons which are directly attached to carbocation are alpha carbon. ताले कोटा कोटा एटा गोटे एटा गोटे एटा गोटे. So, how many numbers of alpha hydrogen? Alpha carbons are there, 3 number of alpha carbon, and alpha hydrogen कितना रहिला 3 plus 3 plus 3, that is 9 alpha hydrogen. Means you can write 9 number of hyperconjugating structures for dot butyl carbocation, and hence the stability. Now, let us move on to the next part, that is fission of a covalent bond. We know how organic reactions are nothing but it is the making and the breaking of the covalent bonds within the reactant molecule, giving you the product. Reactant molecules भितर bond तैयारी हुए भांगे आउ तुमको product मिले. Now, the fission means breaking. Now, the fission of a covalent bond can takes place by 2 ways. दीटा वे रे हिपारिबो. What are they? The cleavage of a covalent bond can take place in 2 ways, that is homolytic cleavage and heterolytic cleavage. दीटा वे रे होची. We will discuss one by one. What is homolysis or homolytic cleavage? Now, if suppose there is one A and B, they are forming a covalent bond. So, A gives 1 electron and B gives another electron. Suppose the bond breaks in such a way that B takes away 1 electron and A takes away 1 electron. जहाँ गोटे गोटे देइथिले गोटे गोटे नहीं गले. Then this leads to your formation of free radical. This leads to formation of free radical, and the type of fission or the cleavage is called homolytic. Homo means same. Both gave 1 electron each, and after the cleavage both will take their electron. समस्ते गोटे गोटे electron नहीं जिवे. Hence equal distribution होबो. Hence it is called homolytic fission. Okay. So, this type of fission in which the shared pair of electron is actually equally shared between the 2 bonded atoms is called homolytic fission. Here there is generation of free radicals. Free radicals. एवढा free radicals कहा जाए, and we will discuss it after some time. We will discuss what are free radicals. Because I have not given any negative sign over A or B. Why? Because remember that these electrons initially belong to them. सेमानंको पाखरे ही थिला. These electron belong to A, these electron belong to B. सेमाने केवल निज निज इलेक्ट्रॉन फेरे कि नहीं गले. So, remember that free radicals are actually neutral species. They are neutral species, and also there is one unpaired electron. Starting ru सब तक कौन होता पेयरिंग होकर रहता नेला पर सेटा कौन है unpaired electron. So what are free radicals? Now free radicals are reaction intermediates having their neutral species formed by the homolytic fissions, and they have unpaired electron. Remember that. एटा बहुत थोड़ा एंट्रांस रे आछि unpaired electron. Unpaired electron थाए. Second रे पढ़िबो what is the uses of unpaired electron. So homolytic cleavage where the shared pair of electron is distributed equally between the bonded atoms, resulting in the formation of two free radicals is called homolytic cleavage. Okay. Now the homolytic cleavage, remember that it is shown by half headed arrow or fish arrow को है. Half headed देखो मैं आधा लिखिनी. This is half headed arrow रे इटा denote करा जाए है ना. How you can remember that? How you can identify that homolytic fission is carried away? Remember, out of these 5 things, you will get one thing there. That is, the homolytic fission always needs high energy. Hence, there must be heat or ultraviolet ray or H nu or sunlight or peroxide or simply लिखा है energy. से जो आरो ऊपर लिखा है कौन एनर्जी. तो तमें सेउठू गेस कर परिबो जे देयर माइट बी होमोलाइटिक फिशन. एटा इंपोर्टेंट है मन रखथो सब तक हला. One of them must be there in the reaction. So example देखो homolysis. Homolysis always takes place, usually it takes place between non-polar atom, non-polar bond. Non-polar bond रे ही the homolytic fission usually takes place between non-polar bond. देखो एटी क्लोरीन निजर गोटे इलेक्ट्रॉन नहीं गला, ए क्लोरीन निजर गोटे इलेक्ट्रॉन नहीं गला. So finally we are getting two free radicals. Mark what is written here, H nu. एई टाइप रो लिखा है एटी H nu किंबा सनलाइट किंबा एनर्जी किंबा तुमर अल्ट्रावायोलेट रे किंबा पेरोक्साइड आ भितर गोटे जिंस एठी लिखा है फॉर होमोलाइटिक फिशन. Now what are heterolytic cleavage? Now heterolytic cleavage hochi if suppose A and B are forming a bond and A गोटे इलेक्ट्रॉन देथो B गोटे इलेक्ट्रॉन देथो. Suppose B is more electronegative than A, then B will always have a tendency to gain that electron. So कौन कहियो सब बड़े निज आड़ को टाणी आउछंतो. So suppose B takes away these two electrons with itself and leave the place. ताले कौन हला A plus and B minus. So what is heterolytic fission? Now if the fission of the covalent bond takes place in such a manner that the shared pair of electron is actually being taken by one of the atom, then it is called heterolytic fission. And remember that heterolytic fission always leads to the formation of ion pairs. कहीं देखो एठी B टा कौन कला, B A रो इलेक्ट्रॉन भी निज सहित नेकी पळेला. So A loses electron while B gains electron, hence A become plus and B becomes minus. So heterolytic fission always give rise to the formation of ion pairs. So heterolytic fission होची कौन, resulting with an ion pair. Shared pair of electron is donated to one of the bonded atoms. Remember then, one of the bonded atom will take away the electron, both the electron. Here There is an example, suppose B is more electronegative than A, suppose B is more electronegative than A, then B will take away the electron. Here chlorine is more electronegative than carbon. So, chlorine takes away the 2 electron and you get a carbon with a positive charge, that is carbocation, and a chloride ion. Similarly, if A is more electronegative than B, then A can take away the electron with itself, resulting in anion A minus and B plus. Here we are showing, देखा एठी केमते देखा होचे पूरा complete arrow रे देखा जाए, जितले कि homolytic fission टा केमते देखा जाए half headed arrow रे देखा जाए. Now let us see what are reactive intermediates. Remember that our chemical reactions takes place the chemical reactions actually proceeds through involvement of certain chemical species. These chemical species are they are very reactive and very short lived. So, बहुत reactive होतांती as well as short lived होतांती. Some reactive intermediates are your carbocations, carbanions, carbons and free radicals. We will discuss one by one. These are the species through which usually most of the organic reaction proceed. आंको भितरे देकी ही एटा कौन करे आमे प्रोडक्ट पाऊ रिएक्टेंट तापरे एटा तयारी हिता है मे बी कि मझरे तयारी थो तापरे आमे प्रोडक्ट पाऊ सेथि पे आंको कुआ गला कोन रिएक्टिव इंटरमीडिएट्स carbocations, carbanions, free radicals and carbons. We will discuss one by one. So, first of all let us see what is carbocations. Carbocation means carbon bearing a positive charge is called carbocation. जदि कार्बन उपरे पॉजिटिव चार्ज अच्छी माने देखो कार्बन ए टाइप रो अछि कार्बन ऑलवेज हैव 4 valency 4 bond with itself. So, suppose this X takes away the electron from the carbon. Now, the carbon will have a positive charge over here and how many number of electrons देखो कितने bond करछि 1 2 3. So, with 6 valence electron. So, carbon bearing a positive charge and with 6 valence electrons are called carbocations. Carbocations are of 3 types, that is primary carbocations, secondary carbocations and tertiary carbocations. How the carbocations are formed? Now, the carbocations are formed by the heterolytic cleavage of a covalent bond when one of the atom takes away both the electron with itself. See, here there is a formation of carbocation because this chlorine is more electronegative than carbon. Hence, there is heterolysis and this chlorine is taking away both the electrons with itself. So, there is generation of C plus. Now, carbocations are classified as primary, secondary and tertiary depending on the carbon on which actually the positive charge reside. को कार्बन जो कार्बन ऊपर पॉजिटिव चार्ज अछि तार डिग्री टा केते ता ऊपर डिपेंड करके इट हैज बीन क्लासिफाइड प्राइमरी सेकेंडरी एंड टर्शियरी. Let's see here this carbon is having a positive charge and this is attached to one carbon only. So, this is degree is 1 degree. Here the carbon which is having a positive charge is attached to 2 other carbon atoms, hence its degree is secondary carbocation. Here this carbon which is bearing positive charge is actually attached to 3 other carbon atoms, hence its degree is tertiary. Stability of the carbocation. The stability of the carbocation is tertiary greater than secondary greater than primary and it can be explained with the help of 2 effects, that is inductive effect and hyperconjugating effect. Hyperconjugating effect we have just discussed. We discuss करथले 15-20 मिनट पूर्वरु. Now let us see what is how the carbocations are stabilized by inductive effect. Suppose you have a deficiency in money, toma pakhare paisa ra kam achi, your father gives you money, you become stable, your mother also provide you with some money, you become more stable, and your sister also supply or give you some amount of money, then you becomes more stabilized in terms of financial gains. Similarly, this carbon is deficient in electron. So, if somebody is supplying electron to this carbon, it becomes more and more stable. Eta kon hobo sette adhika stable he chalibo. Tertiary, in case of tertiary carbocation, 3 alkyl groups are actually supplying electron to this carbocation, hence it is the most stable one. Then in case of secondary, 2 alkyl groups are supplying electron to this carbocation. On the basis of inductive effect, I am explaining this. And in case of primary, only 1 alkyl groups is supplying electron to this carbon. So, the degree of stability will be tertiary greater than secondary greater than primary for stability of the on the basis of inductive effect. Now, hyperconjugation, how the carbocations are stabilized by hyperconjugation, I have already discussed it. So, in case of taught butyl carbocation, the number of alpha hydrogens are high, hence more is the stability. Let us see the orbital structure of carbocation. I have already taught you how to calculate the hybridization in an organic compound. You just calculate the number of sigma bond. Here the carbocation forms 3 number of sigma bond, 1, 2, 3. So, if 3 number of sigma bonds are formed, means its hybridization is sp2. So, if the hybridization is sp2, the structure will be planar. The structure will be planar. It is the structure of the carbocation is planar. एगुड़ा दरकार आसिबो केतबेले हम जेतबेले सेकेंड ईयर रे पढिया रिएक्शन मेकानिज्म. So its structure will be planar with a vacant pz orbital. एठी गोटे फांका pz orbital अछि ना. So this is the structure of the carbocation. Entrance रे आसे structure आउ तार angle गुडा को. Now let us discuss another reactive intermediate, that is carbanion. As the name is suggesting itself, it is the carbon bearing negative charge over it. जेकोनोसी कार्बन तापरे नेगेटिव चार्ज जदि अछि and it has 8 electron in its valence cell. These are called carbanions. माने कोन कह जाय carbanions कह जाय. Like carbocations, how the carbanions are produced? The carbanions are also produced by the heterolytic cleavage of the covalent bond, in which the shared pair of electron remains with the carbon atom. For example, suppose I am writing carbon and there is a group attached to it. Suppose this group left, the carbon takes the electron with itself, it becomes C minus, and the group left without any electron, then there is the formation of carbanion. It is kon tiyari hela? Carbanion tiyari hela. Let us see an example. Here mark that the OH minus ion takes away one H, that is the base is taking away a proton H plus. Eta H ta kenti gala H plus. It is being removed H plus. So you will have water plus CH2 minus CHO. This is a carbanion. This is an example of carbanion. Now, similar to that of the carbocation, carbanions are also divided into 3 types, that is primary, secondary and tertiary, depending upon the carbon on which the negative charge reside. Ko carbon upare negative charge achi. If the charge is on the primary carbon, then it is called, if the charge is present on a primary carbon, then it is called primary carbanion. If the charge is present over a secondary carbon, it is called secondary carbanion. if the charge is present over a tertiary carbon, it is called tertiary carbanion. Now, let us see the stability of the carbanion. The stability order of carbanion is primary greater than secondary greater than tertiary. It is just the reverse of that of the carbocation stability. Carbocation stability ro kon just opposite ta hochi. Why? Because this can be explained with the help of the inductive effect hela. Eta kon hobo inductive effect re ame bujhei pariba. For example dekho, suppose tome bahut khai decho, तुमको नहीं कहे आउरी खा, will you agree with me? No, because you are already full. Similarly, let us see an example. Mark that the carbon here is actually having negative excess electron is already present over this carbon. So, if you are supplying it more electron, it will be reluctant to take. For example, in case of primary carbanion, only one alkyl group is supplying the electron. In case of secondary carbanion, two other alkyl groups are supplying electron to the carbanion, and in case of tertiary carbanion, three alkyl groups are actually supplying its electron. So, will it be stable? No. The stability order will be 1 degree greater than 2 degree greater than 3 degree. Also the we have already discussed it, and here mark negative charge, single bond, double bond, there is conjugation. So, according to resonance, the stability of this allyl anion can also be explained in terms of the resonance. Now, let us see the structure of the carbanion. The structure of the carbanion, you calculate the number of sigma bonds 1, 2, 3, and remember that you have to consider also the lone pair of electrons. So, how many number of how many numbers of electron pairs are there? 1, 2, 3, 4. So, 4 number of electron pairs are there, means the hybridization is sp3. That is a pyramidal structure type of this ammonia structure one paka. Its structure is like similar to that of the ammonia. Here there is the lone pair, and here 1, 2, 3. This is the structure of the carbanion. So, with this I am finishing today's class, and in the next class we will discuss the free radicals and different types of organic reactions. Okay, thank you. Have a good day. Take care.